In this example, we're really going to start looking at how we can use Solver to come up with the ultimate solutions. So as we're looking at this, we have the PC Tech Company assembles and tests two models of computers, the Basic and the XP. For the coming month, the company wants to decide how many of each model to assemble and then test. No computers are in inventory from the previous month, and because the models are going to be changed after this month, the company doesn't want to hold any inventory after this month. It believes that it can sell this month are 600 basic and 1200 XPs. Each basic sells for 300 and each XP sells for 450. The cost of the components parts is 150 for the basic, 225 for the XP. Labor is required for both the assembly and the testing, and at most there are 10,000 assembly hours and 3,000 testing hours available. Each labor hour for assembly costs $11 and each hour for testing costs $15 an hour. Each basic computer requires 5 hours for assembling and 1 for testing, and each XP computer requires 6 hours for assembly and 2 hours for testing. PC Tech wants to determine how many of each model that it should make to maximize profits. Okay, so looking at it, we've got, with any of our optimization stuff, we have 3 things that we're always going to be looking for. The first is the decision variable. What is the decision variable? This is what I get to pick. You get to pick. We decide what, that's the decision. That's what we're trying to figure out. We have the objective. What is the objective? The objective is whatever we're trying to achieve. And then the last thing is, we'll put a colon there, last thing that we're going to have is constraints. What are constraints? Constraints are the material, the sales, whatever the maximum and minimum are for each of these things. Okay, so let's start with our decision variables. As we look at this problem, we get to decide not one thing, but we do have 2 things that we're allowed to decide. And so what are those? Well, our first decision variable, which we'll call x1, is the number of basic computers. The number of basic computers that we're going to assemble and test. And our second decision variable, because we do have 2, is the number of XP computers. Okay, so this is what we're allowed to pick. We've got 2 different things. Okay, and so those are our decision variables. That's what we're ultimately trying to find. So what's our objective function? Well, what are we trying to do? We're trying to maximize profits. A lot of times in a business setting, the objective is going to be a lot of maximizing profits. So, what is the profit? Well, the profit is the revenue minus the component cost minus labor cost. And the labor cost is both assembly and testing. Okay, so if we look at that, we look at the basic profit per computer. Now this would be the basic computer. What is that going to be? Well, the basic profit is going to be a revenue of $300 minus $150 of component costs. And then we have the labor costs. So we'll subtract from that the labor cost for assembly. It's 5 hours times $11 per hour. And then for testing, it's 1 hour times $15 an hour. So that would be the objective, that would be the profit for the basic computer. We can do the same thing for the XP. XP profit per computer. And so the XP, the revenue is $450. We're going to subtract from that $225 for part cost, 6 hours of assembly at $11 an hour, minus 2 hours of testing at $15 an hour. And so actually if we go, so this first one, if we actually crunch all those numbers, our profit will be $80 for every basic computer. And if we go down here and do it here, our profit for the XP computer is going to be $129 per computer. So the function for this profit's going to be X1, which is the number of basic computers that we make, times $80, because for every basic computer we'll make $80. And then we're going to add to that X2, which is the number of XP computers that we have, and then we'll multiply that by $129. So that's our basic profit function for our setup in terms of our decision variables, because the objective is always going to be, somehow we're going to trace back to those decision variables, the objective. Okay, and so now let's talk about constraints. Once again, constraints, these are the things that stop you from just going, well, we make more money on the XP, so we're just going to make nothing but XPs. That can't happen because there are things that stop it. So the first thing is we have a sales constraint. So they've come to us and said, okay, well, you know, we can sell no more than 600 basic computers. Okay, so I've got these 600 basic computers. And so that tells me that X1 is going to be less than or equal to 600. Because if I just do less than, that means I can only get to 599. What's the other constraint? Sell no more than 1200 XPs. Okay, what does that mean? Well, that tells me that X2, the number of XPs that we're going to sell, have to be less than or equal to 1200 computers. So there's our sales constraints. Okay, our next constraint is our labor constraint, because we're constrained by the amount of labor hours that we have. Okay, so what are our labor constraints? Well, for assembly, we know that we only have 10,000 hours. So basic computers, 5 hours times how many ever basic computers that we make, plus 6 hours of assembly for the XP, times how many ever XP computers are going to make, X2, that has to be less than or equal to 10,000 hours, because those are that's all the hours that we have for assembly. And then we have testing. So testing, same kind of thing. Well, it's 1 hour for the basic computer times the number of basic computers, plus 2 hours times the number of XP computers. That has to be less than or equal to $3,000. Or, sorry, 3,000 hours, because those are all in hours. We do have one final constraint, and that's our non-negativity constraint. And so, basically, what does that mean? That means that the number of computers that we're making can't be negative. Now, I know that makes a lot of sense, because you're like, well, obviously it can't be negative. But it's a common constraint that we have to think of, because obviously if we could go negative with some of these things, it frees up hours. So it's just, we have to think about that. So X1, X2, both have to be greater than or equal to 0. So that's our non-negativity constraint. So if I look at that then, what is my optimization model? So my optimization model is I want to maximize 80 times X1 plus 129 times X2. And it's held to what constraints? Well, we've got the first one, which is 5 times X1 plus 6 times X2 has to be less than or equal to 10,000. Actually, I can just control copy my next constraint is 1 times x1 plus, it has to be less than 3,000. And then I have my demand constraints. And then finally, I have my non-negativity constraint. Okay, so now we're not going to go solve this by hand because we are just going to do it using Solver, which is a plugin that is in our Excel program. But this is how we think about it and set it up. Now, truthfully, maybe not in this much detail, but before you go to do any solver problem, you should kind of sit down and just maybe with a pen and paper, scratch out this kind of stuff. Identifying your decision variable, your objective function, your constraints. Because as you do that, it's going to make the rest of the problem a lot easier putting together. So now that we know what our optimization model is going to look like, in the next video, we're actually going to put this into Excel and have it solve that optimization for us.